Let's see the correct method of reading a clinical thermometer. In order to read the thermometer, we have to hold it firmly and give it a few jerks. The jerks will bring the level of the mercury down. Ensure that it falls below 35 degrees Celsius. And then we have to place the bulb of the thermometer under our tongue or the patient tongue. After 1 minute, we have to take out the thermometer and we have to note the reading as we have discussed in the last topic, how to read the temperature. So the point up to where the mercury level reads will be our body temperature. The temperature should always be stated with its unit, that is in degrees Celsius or in degree Fahrenheit. We have to remember that a normal human body temperature is normal temperature of human body is 37 degrees Celsius. And if it measures in degree Fahrenheit, then the normal body temperature of human body will be 98.6 degree Fahrenheit. We have to remember this temperature for the normal body temperature. Let's see how the normal body temperature is measured. It is the average body temperature of large number of healthy persons. So we call the normal temperature is the average body temperature of a large number of healthy persons. The clinical thermometer is designed to measure the temperature of human body only. The temperature of human body normally does not go down below 35 degrees Celsius, and it does not go above 42 degrees Celsius. That's why the clinical thermometer have a range of temperature from 35 degrees Celsius to 42 degrees Celsius. So we have not to use the clinical thermometer for measuring the temperature of any object other than the human body, which is below 35 degrees Celsius or which is above 42 degrees Celsius. By doing so, the thermometer may break. So in order to do that, there is another thermometer called laboratory thermometer. Let's see what is laboratory thermometer. It is a thermometer which is used to measure some items like hot water or acids, which are generally kept in a laboratory. It has a temperature range from minus 10 degrees Celsius to 110 degrees Celsius. We know that the water freezes at 0 degrees Celsius and the water boils at 100 degrees Celsius. So with the help of this laboratory thermometer, we can measure the items which is even below 0 degrees Celsius and which is even above 100 degrees Celsius. This is the clinical thermometer which is used in measuring temperature of hot water. In order to measure the temperature of hot water with a laboratory thermometer, we have to put this laboratory thermometer upright, positioned like this. And after we hold it for some minute, the mercury will rises up to a height, and if the mercury rise stop here, then we can know that the temperature of this water will be the reading at this mark. In this example, the reading is at 80 degrees Celsius. There is a lot of concern over the use of mercury in thermometers. Mercury is a toxic substance and is very difficult to dispose of if a thermometer breaks. These days, digital thermometers are available which do not use mercury. So this is a picture of a digital thermometer. In this digital thermometer, mercury are not used. This digital thermometer uses a digital display and a battery. The reading will be shown in this display. Next, let's do an activity. In this activity, we will take a metal rod and we will put some wax with an equal distance like this. And we will put a flame, it may be from a candle, and we will hold a stain. We will fix a stain like this in order to hold this metal rod. So at first this flame will hit this one, and after some time the first wax that attached here will becomes liquid and it will drop, and after some time the next wax will be drop, and the third one, and then after some time the fourth one, and then the fifth one, and so on like this. So from this activity we can conclude that this heat coming from the flame is transferred to another body by a process known as conduction. So it is the process by which heat is transferred from the hotter end to the colder end of an object. Let's see the next topic, transfer of heat. Okay, we know that a frying pan becomes hot when it is kept on a flame, and when we remove this frying pan from the flame, and after some time it becomes cold. So from this activity or from this thing, we can say that heat flows from a hotter object to a colder object. Okay, let's see. Okay, at the beginning the pan was cold, and when it is kept on the flame, the temperature of the flame is much more as compared to the temperature of the pan. So the heat from the flame will transfer to the pan. And when we kept the pan away from the flame, at that time the temperature of the frying pan will be more as compared to the surrounding. So the heat from the pan will transfer to the surrounding. That's why the pan becomes cold. So remember this one, heat flows from a hotter object to a colder object. Next, we can do another activity. In this activity, we will put some different objects, maybe plastic scale, pencil, divider or spoon or anything that can put inside this glass. And after that we will put some hot water, maybe about half level of this glass, and we may put this for about minutes, and after that we can test the different objects one by one. In this case, some objects will become hot and some objects will remain as it is. That is, it will not change its temperature. The object that becomes heat is actually transferred from the hot water. So we can term the objects as conductors of heat and insulators. So let's see what are conductors and insulators. The first term is the conductor. These are the materials which allow heat to pass through them easily. We can say some example of the conductors are aluminium, iron, copper, etc. And another term is the insulator. Okay, these are the materials which do not allow heat to pass through them easily. Here the insulator can also be named as poor conductor. Some example of insulator or poor conductors are plastic, rubber, etc. We can do another activity. In this activity, we take a beaker and fill it half with hot water. Let us take 2 spoons made of a metal such as steel and the other made of plastic. We will place the metal spoon and the plastic spoon in the beaker containing the hot water. After about 2 minutes, we touch the top ends of both the spoons with our hand one by one. We will find that the top end of metal spoon feels quite hot, but the top end of the plastic spoon does not feel hot. This is because heat from the water, that is the hot water, flows easily through the metal spoon and reaches its other end. But the heat does not flow easily through the plastic spoon, due to which its other ends remains almost cold. This activity tells us the metal spoon is good conductor of heat, whereas the plastic spoon is a poor conductor of heat, or we can say is the bad conductor of heat. We say that plastic is an insulator of heat. Okay, there are uses of good conductors and poor conductors of heat. We make use of good conductors of heat as well as of poor conductors of heat or insulators of heat in many ways in our daily life. Say, for example, in this frying pan, the metal pan is a good conductor of heat. So the heat from the flame can easily transfer to the metal pan, and again from the metal pan it can hit the food item which we are cooking. And in order to handle this frying pan, the handle is made up of the poor conductor of heat, which may be of wood or the plastic. Since the wood or the plastic is a poor conductor of heat, the heat from the metal pan will not transfer to this handle. So we can hold this frying pan without the risk of the heat. And in the pressure cooker also the same thing happen. The cooker, that is the part in which the food item will be put, is made up of a metal, and the part which we are going to hold by our hand is made up of a plastic, which is an insulator, that is the poor conductor of heat. So the heat from the flame can easily transfer to this metal cooker in which the food is cooking, and the heat from this metal part cannot transfer to the handle. So we can hold this handle very easily without a risk of heat.